Formulae of hydrated salts. This tutorial covers example questions for working out what the formula of a hydrated salt is given its mass and mass after heating. In chemistry, we often talk about salts without mentioning the fact they have some water associated with them. If they are a powder, they are often anhydrous, which means they have no water present. And if they are crystalline, they probably have some water associated with them and are known as hydrated salts. You might have used blue cobalt-2 chloride paper to test for water. It is paper with anhydrous cobalt-2 chloride present, and if water is added it turns red due to the formation of hydrated cobalt-2 chloride, or to be more precise, cobalt-2 chloride hexahydrate. If we look at the formula of cobalt-2 chloride hexahydrate, we can read it as for every 1 mole of cobalt-2 chloride, there are 6 moles of water present. The notation used is the formula of the salt, followed by a dot, and then the number of moles of water present. This question is asking us to calculate the number of moles of water present per mole of zinc sulfate. If you note, it states an initial mass and a final mass. It states that the loss of mass is due to the loss of water. So you could calculate the loss of mass due to water, so 1.55 minus 1.08, which would probably give you a mark. Also, as molar masses are present, probably what you could do is calculate the number of moles of zinc sulfate and moles of water present for another mark. As questions are often about ratios after converting masses to moles, you might then consider getting a whole number ratio of moles of zinc sulfate to water, and then you've basically solved the question. So going through this step by step using a table. Firstly, draw a column for the salt and also for water. Write down the masses of each present. Then calculate the number of moles of zinc sulfate and moles of water present using the molar masses. Now divide through the number of moles present by the smallest number of moles present. In this particular case, it is the number of moles of zinc sulfate. In general, for hydrated salts, there's going to be more moles of water present than moles of salt present. 3.89 is quite close to 4, so you can say the ratio is 1 to 4. So the ratio of zinc sulfate to water is 1 mole of zinc sulfate to 4 moles of water. Thus, the empirical formula is ZnSO4.4H2O. This question is asking us to calculate the number of moles of water present per mole of magnesium carbonate. Even if you are not sure what to do regarding mole calculations, you could calculate the mass of water lost due to heating, giving you a mark. As molar masses are given, this suggests you should work out the number of moles of salt and water present for another mark. As ever, we draw our table and draw one column for each of the compounds which is present. We can write down the masses. Using the molar masses, we can calculate the number of moles present. Formulae for compounds in chemistry have whole numbers, and it states in the question that it is 1 mole of magnesium carbonate to a certain number of moles of water. So, if we convert 0.09 moles of magnesium carbonate to 1 mole of magnesium carbonate by dividing it by the number of moles present, so dividing it by 0.09, we should also do the same to water, as we have calculated it as a ratio of 0.09 moles of magnesium carbonate to 0.45 moles of water. This calculation gives us the result: there is 1 mole of magnesium carbonate to 5 moles of water. So the simplest ratio of compounds is 1 mole of magnesium carbonate to 5 moles of water. The empirical formula is MgCO3.5H2O.